Look at the sheer scale of the structure. It is a 12-story, intricately curved concrete building standing at the peak of a mountain. Covering this surface with a protective stone skin by placing pieces one by one, suspended hundreds of meters in the air, was physically impossible. In the 1920s, engineers faced a massive problem. At 700 meters above sea level, hurricane-force winds and extreme thermal stress would inevitably crack and destroy raw, exposed concrete. Engineer Heitor da Silva Costa needed a way to bypass traditional masonry entirely. His solution was a technique we now call mineral wallpaper. Today, we are going to build a weatherproof stone-clad panel by executing his exact manual technique from 1931. To pull this off without setting a single stone by hand, you need 4 materials. First, raw soapstone, heavy linen paper, water-soluble glue, and fresh cement. Step 1 is sourcing and prepping our steatite, better known as soapstone. This diagram shows our exact target dimensions. We need to cut the raw stone into precise triangles, measuring exactly 3 centimeters on each side and 1 centimeter thick. When you start cutting, you will immediately notice the stone feels incredibly soft, powdery, and almost like talc. That is exactly what you want. Steatite possesses a unique chemical property. While it is incredibly easy to carve out of the quarry, it chemically hardens and becomes completely impermeable only after it is exposed to the outside elements. Because concrete is porous, it naturally absorbs moisture and cracks during temperature swings. This stone provides the solution. It hardens into an impermeable shield that blocks water from reaching the internal steel, ensuring the structure doesn't rot from the inside out. Step 2 is assembling the canvas. Whatever you do, do not attempt to press these small stones directly into wet cement one by one. Instead, we are going to lay out a heavy-duty sheet of linen paper and coat the entire surface with a water-soluble adhesive. Place the 3 centimeter triangles flat onto the glued paper, leaving tiny uniform gaps between each piece. This reverse assembly allows a rigid surface to behave like a flexible skin, wrapping tightly around the monument's complex curves. Step 3 is the historical secret. Once your glue is completely dry, flip the entire sheet over so the unglued, porous backs of the stones face up. Write a secret message, a name, or a wish directly onto the exposed stone. In the 1920s, thousands of women from the parishes of Rio de Janeiro did exactly this. They created a hidden layer of personal wishes that remains permanently sealed against the monument's concrete heart to this day. Step 4 is the final application. Prepare a thick base layer of wet cement. Orientation is crucial here. Press the assembled sheet into the wet cement, with the stones facing down into the mix and the blank linen paper facing toward you. The paper backing provides a massive mechanical advantage. When you smooth the paper with a trowel, you distribute pressure evenly across thousands of stones at once, completely eliminating trapped air bubbles. That flawless, bubble-free contact permanently seals the underlying porous concrete from deadly tropical moisture. Step 5 is the reveal. Let the cement fully cure and harden. Carefully dampen the linen paper backing to dissolve the water-soluble glue. Then, slowly peel the paper away to reveal the embedded stones underneath. You have achieved a perfectly flush, permanently set mosaic, all without having to individually place a single stone into the final wet cement. Take a look at your finished panel. Because we used a flexible paper transfer, the entire surface is flawlessly flush and uniform. You will also notice the aesthetic payoff. Rather than a flat gray, the surface is a faceted skin made of tiny fragments that catch and reflect the light dynamically from different angles. Scaling this manual microengineering up to 6 million pieces is what allowed this concrete spire to withstand a century of storms at 700 meters above the Atlantic. Engineering requires complex structural math, combined with the manual ingenuity to dream vertically. If you want to master the techniques behind more of history's greatest architectural challenges, subscribe to the channel.